Six. I actually, when I'm teaching in a computer, na, I'm not feeling good actually. You want only computer, huh? Screen, huh? Okay, very good. So as for the sleep teaching portion, first of all, Coulomb's law is there. Today, our discussion about Coulomb's. Okay, so today's our discussion about Coulomb's law or analogous universal law of gravity. Already in your 11th standard, you are very thorough about the universal law of gravitation. Understood? 99% of the all physics principles copied and pasted from this universal law of gravitation. If you have doubt, please check it. I will write the equations. What is the gravitational force between two masses? Equal to how much? G m by r. There would G m1 m2 by r square. Now here see Coulomb's force. I mean electric force between two charges. How it looks like F equal to K into Q2 by r square. Even in the magnetic force also between two magnetic poles also will be how much? K into pole strength by r square. Now check it out. Even intensity of the light also looks like this equation. Are you understanding? So most of the principles, okay, copied and pasted are unofficially inspired from the universal law of gravitation. Okay, so now today our discussion is Coulomb's law. One limitation also there for Coulomb's law. It is valid for only very good point charges. Point charges, what is the meaning of that? In reality, no charged body is a point charge. But any big charged body, when it looks like a point charge, very good. When the separation between the two charged bodies are very large enough, even very big object is acting like a very small object. Students, especially new student, any doubt, please stop me immediately. Here, what is your name? Okay. Any doubt, feel free to ask. Why? Because one doubt will create thousands of doubts. That first doubt, if you
Sir,
get the clarity, 990.
sir,
Yeah. Who is that?
Vishwanath, sir. Sir, can you hear me?
Yeah, I can hear you, Vishwanath. Please speak.
Sir, can you explain a bit of points, sir, again?
Yeah, point charge. You are seeing sun actually. How the sun reality is very big. But you are seeing from the Earth planet how it looks like, just like a point only, na? We say yes or no. Even moon also, all small stars also you can see as a point masses. Any extended body appear like a point charge when the separation is very larger. I am telling. Are you understanding my point? Understood. So
If distance is more, it looks like point charge, sir.
what here?
From the viewpoint, if distance is more, it acts as a point charge, sir.
Yeah.
Okay, sir.
For example, if you take the duster, some charge is there on the duster. You are seeing from very near, you are seeing that as an extended charged body. Some, for example, 1 kilometer distance, if you are watching this charged body, how it looks like? Point mass, not visible, not little tiny mass, point mass. Yes, sight now. That's what. So, understood. So, for example, take 2 point charges, Q1 and Q2. Harish, it will happen. Okay. Okay, so there are 2 point charges. Okay, what are the separation? How much? R. Now, see their signs. Both are positive sign convention. Both are in the free space. Free space means they are free to move. Free to move in the sense in which direction that force is acting. In the same direction, they start moving. You know very well, like charges repel each other and unlike charges attract each other. Right now, Q1 will repel Q2 away. That is action. What is reaction? For every action, there is an equal and opposite reaction. So Q2 also will repel with the same force. And one more very important thing: these two forces never act on single charge. Action is acting on Q2, reaction is acting on Q1. But the magnitudes are remaining same only. Experimentally, the magnitude of the force is directly proportional to what here? Product of the two charges, and inversely proportional to what here? Square of the inversely proportional to square of the distance. If you combine this equation, what you get? F equal to one constant I will keep, that is K into how much? Q1 Q2 by R square. Here K is called here proportional constant. I told you many times, every proportional constant will represent the nature of the medium in between the two charges. That or not? You check any standard equation, understood? It implies the nature between the two charges, medium between the two charges. So that K value how much here? K is called proportional constant. What is K value here? 9 into 10 power 9 MKS units. 6 units MKS units. You can also write K equal to how much? 1 by 4 pi epsilon naught. Yesterday only in the discussion I have explained what is the concept of the permittivity. In a region, 100 electric field lines are there. Different medium will permit differently. Understood? Metals will permit 100% of the electric field lines. So different media will have the different permittivity. Ability of any medium to allow the electric field lines through it is called permittivity. Right now, in between the two charges, which medium is there? Air or vacuum or free space. So what is the permittivity of the free space or vacuum? 8.85 into 10 power minus 12 MKS units. So point clear?
What is
Huh?
what is log?
Epsilon naught value. Permittivity of the air or free space. Understood? If you fill any some other medium, instead of air, instead of free space, you pour some liquid. Then you have to take what here in the place of epsilon. Permittivity of that liquid you have to take. Understand? So very strictly, it is applicable for only point charges. Let us see some situations here. Once we will enter into atoms. How it looks like atom according to Bohr's atomic model? It is a sphere. It is a center. Nucleus is there. Please respond. What is the charge of the nucleus? Q1 equal to number of protons, means atomic number into charge of each proton. I am taking, according to Bohr's atomic model, different electrons revolve around the nucleus in the different circular path. That path is called orbit. Again, orbit will split into orbital. Again, that is chemistry we are going. So we are confining only up to orbit only. So I am taking any one of the orbit. One electron is revolving in the anti-clockwise direction. With what speed? Let's say d meter per second. According to Bohr's atomic model, any electron revolving with a constant speed and constant kinetic energy, constant total energy. Are you understanding? My question is very simple and straight. To keep this electron in the circulatory orbit, which force is compulsory? Centripetal force. Who is providing the centripetal force? Nucleus. I mean, the unlike charges attract each other. Even electron also pulling the nucleus towards its center, but it is a quite heavier. Correct or not? So this is just like how many times? Several thousand times larger than electron. So it will not relocate from its location. Only electron will be affected because of the centripetal force. Throughout its lifetime, it is revolving in the circulatory orbit. Tell me what is charge of the electron? Q2 equal to minus E. Here I can write one statement. The centripetal force completely provided by what? Electric force. Someone tell me what is the centripetal force formula? Very good. Mass of the electron, speed of the electron, whole square. Let's say the radius of the circular orbit, how much? Small r. That equal to what is the electric force between the two charges? Very good. K into Q1. Q1 value how much? Z into E. What is charge of the electron? E. Inside the nucleus, how many types of charges will reside? Protons and neutrons. Neutrons zero charge, na? So total charge equal to charge on the all protons. Every proton has charge E, no? How many number of protons are there? Z, atomic number. Clear, na? Helium atomic number 2 means inside the nucleus 2 protons are there. Understood? 2 neutrons are there. Okay. So I can write divide by how much? What is the distance between the two charges? Very good. R square. Small r cancels out. Minus not required. Only we are talking negative force means you are correct, Vishal. Minus I have to keep. Negative force is representing just attraction. Everyone knows, na? So we are investigating only magnetic force. Understood? R cancels out. So what I can write? Speed of that electron how much? Under root of how much? K into Z into E square divided by mass. Into R. That is the velocity of the electron. So this is a very simple system. System of two simple charges. So now this is only system of very two simple charges, 2 point charges. Let us extend this discussion for 3 charges, next 4 charges, etc. For suppose I am taking one equilateral triangle. What is this? One is equilateral triangle. 3 identical charges I am keeping. This is one plus q. Here is one plus q, and here is one plus q. Let's say the length of the each side is how much? A meter, and A meter. And also, you know, angle between two sides how much? 60 degrees. Now, let's say this is charge number 1. This is charge number 2. This is the charge number 3. Tell me what is the total force on any one of the charge? For example, I am finding total force on this charge Q. How many forces are there? 2 forces. Every charge will experience 2 forces. Second charge will repel like this. That is F Newton. Third charge also will repel like this. Yes or no? That is also F Newton. Why I am confidently rating 2 F's same? Equal charges and equal distances. Subsequently, this is 60 means naturally this is also how much? 60. According to parallelogram law of vector addition, if you extend this force, the diagonal of this parallelogram is representing net force on that charge. Someone tell me what is net force on this each charge? There is under root of how much? F square plus plus 2 into F square. So there is cosine of 60. Cosine 60 and 2 cancels out. Understood? What net force equal to? Respond. Net force equal to how much? Under root of Vf square. So net force equal to how much here? Root 3 into F. F is nothing but force between 2 point charges. What is force between 2 point charges? Respond, Arvind. Force between these 2 point charges, tell me. Force between this charge, tell, right? What is formula? A into Q into Q by what is distance between them? A square. That is the total force acting on this point charge. But direction also we can find out. For direction we can write alpha formula how much? According to parallelogram law of vector addition, very good, tan inverse of F2 sin 60 divided by how much? F1 plus F into cosine of C. F cancels out. So what direction also tan inverse of sin 60 means how much? Root 3 by 2 whole divided by 1 plus 1 by 2 how much? 3 by 2. 3 by 2. 2 cancels out. What is tan inverse of 1 by root 3? Root 3 by 3 means what? We can write root 3 into root 3. Root 3 cancels out. So tan inverse of how much? 1 by root 3 means directly 30 degrees. Is it clear, everyone? Let us see one more situation.
But we are finding force only, sir.
The total force.
Where is the velocity?
Velocity not required. They are not orbiting. Just they are. If they are in the free state, this charge will accelerate like this. This charge will accelerate like this. This charge will accelerate in the straight path like that. No orbiting. Yeah. Now here, neutral point. The name only it is there. What is the meaning of the neutral point? The point where the net external electric force constant should be 0 is called neutral point. For example, this is one point charge Q1 is there. This is one point charge Q2 is there. Both are positive charges. One may be small, one may be very big. What is their separation response? Small d meter. Definitely, one particular point P, what will happen? Just imagine then at point P actually there is no charge. In the gravitation also, if nothing mass is there, we can assume one test mass. Na? Yes or no? So here also at point P, no charge is there. So we have to assume one test charge. Someone tell me what are the characteristics of the test charge?
Mass must be
Test charge is charge must be 1 coulomb or unit, and it should be free, and it should be positive.
not affect that.
Very good. It should not affect any system. Understood? So now here I can assume point B. What I can assume? What I can assume? Tell me.
Therefore is 0.
At point B I can assume this 1 coulomb charge. Nothing is there. In fact, no charge is there, but I am assuming 1 coulomb charge. Now tell me on this 1 coulomb charge, how many forces are experiencing? I said net force must be 0, no? Means Q1 charge will repel like this and is nullified by F2. So yes or no? So both forces are equal and opposite. Yes or no? Understood? I will assume this is a null point or neutral point is a distance how many meter? X meter. Once again I will redraw. This is a point charge Q1. What is this point charge? How much? Q2. What is their separation? D meter. Where I assume neutral point? At point B, at some distance, how many meter? X meter. At point B, compulsory you have to assume which charge?
Point charge.
One coulomb charge. This 1 coulomb charge is repelled by Q1 away like this. Q2 also repelling 1 coulomb away like this. F1 is nullified by F2 only, na? Then only the net force at point P, how much it will be? 0. Hence that point P is called what here? Neutral pointer, null pointer, 0 force point also if you call, no problem. Shall I write one statement F1 equal to F2 like that? Shall I write? Who came late? Please watch the recording. Recordings are sharing. Okay, so I can write F1 equal to how much here? F2 I can write. You people respond. What is force between 1 coulomb? Equal magnitudes. Nourish. This is 10 Newton means this is also 10 Newton.
Sir, but distance is different.
Magnitudes also different, knowledge. For example, just imagine this is 1 microcoulomb charge is there. This is 2 microcoulomb charge is there. Where neutral point will be residing? Very close to smaller charge. The smaller charge is nullified by small distance, compensated by small distance. Correct or not? So if you assume 1 coulomb charge here, 2 microcoulomb with what magnitude is repelling? 1 microcoulomb also repelling with the same force. Understood or not understood? Now I can write very confidently F1 equal to how much here? F2. That too magnitudes only. I mean positive sign only you have to consider. F1 means force between Q1 and 1 coulomb only, na? What is force F1 value? K into how much? Q1 into 1 whole divided by how much?
X square.
X square plus equal to what is force between Q2 and 1 coulomb?
Very
Very good. K into Q2 into next charge by B minus X power 2. 1 cancels out, K cancels out. B minus X I am sending left side. So what I can write here? B minus X by X whole power 2 is equal to how much? Q1 I am taking to denominator. So what we can write? Q2 by Q1. Square if you send that side, what will happen? It will become under root. So I can write what here? B minus X by X equal to how much? Under root of Q2 by Q1. Okay. So d by x I can write like this. And minus x by x how much? 1 equal to how much? Under root of Q2 by Q1. Minus 1 I will send that side. So what I can write here? D by x equal to how much? 1 plus under root of how much? Q2 by Q1. X I am sending this side to numerator. This total thing I am sending left side to denominator. So what is the position of the neutral point? B divided by how much? 1 plus and under root of Q2 by Q1. Are you understanding? One question I will ask you people have to do it. This is 1 plus 1 microcoulomb. This is 1 minus 1 microcoulomb. Sorry. This is, let's say, minus 2 microcoulomb. They are separated by some distance, let's say 2 centimeter. Find the, write down the question, find the neutral point from plus 1 microcoulomb. Find the neutral point or null point from 1 microcoulomb. 2 minutes time. Everyone have to give the answer. Simple problem. Do not think about correct answer. Concentrate on present step only. 100% you will get correct.
Hey, it doesn't matter.
2 by 2 by
1 plus
1 plus.
whether minus root will come or plus root will come. Yes, sir. 2
by
by
1
1
also, your answer should be very accurate.
2 by 1
Probable answer please do not.
minus allowed. Minus 1 plus 1. Minus 2 by
1.
Only magnitude. Only magnitude.
Magnitude and distance also I want.
1 plus root 2. Sir, 2 into 1 plus root
1 plus root 2.
No, sir. 2 by 1. 2 by 1 plus root
2 by 1 plus 2. This is Geo answer and Parvez answer.
Sir, 2 into 10 power minus 2.
2 into 10 power minus
Centimeter.
by.
Sir, by 1 plus. Sir, this answer is in meters, sir.
Okay. No problem. By
1 plus root 2.
1 plus root 2.
Microcoulomb.
Okay. This is Harish answer. Same also. Okay. Okay, now let us check where you will obtain neutral point. Can you obtain neutral point here? I will check randomly. This point P is there. Can you obtain any neutral point here? No. Why? No chance of nullification. Why? Because at point P assume which coulomb? One test charge, 1 coulomb you assume. This positive charge will repel or attract? Will repel. Minus 2 coulomb will attract or repel? Attract. So both forces are in the same direction. Is there any chance of nullification? No chance of nullification. So 100% neutral point will not reside in between the two charges. Yes or no? Either left side or right side. We have to detect it first. Left side I will check any random point P. What will happen here? 1 microcoulomb will repel, no? And minus 2 microcoulomb will attract. There are high chances are there. Right side, why it can't be? Minus 2 microcoulomb will attract very strongly. Because minus 2 microcoulomb is very near, na? Say yes or no? Understood or not understand? But 1 microcoulomb, very feeble force it will produce. Why? It is very far. So 100% here no null point will form. Here also no null point will form. 100% neutral point or null point will form only on the left side only.
Why is it not being between?
Already I gave justification also, na?
This side attractive force is there.
This side
Minus 2.
you take any point. I think your problem I told many times. When I am telling, na, your brain will be 10 seconds lagging. Correct? Honestly, correct.
It can be near minus 2 coulomb also.
Look here, see, take any one point P here. What you have to assume?
Null point. Okay. Now point that.
Test charge plus 1 coulomb you have to assume.
Yes, sir.
Understood? So this plus will repel or attract?
Repel.
Will repel. Minus 2 will attract or will repel?
Attract.
Attract means how these two forces will nullify. Understood? Okay. I did not tell anything newly. Same thing I explained.
Instead of 1 plus 1 minus under denominator. Instead of 1 plus root 2, put 1 minus root 2.
1 minus root 2. Okay. Harish corrected. Understood? I told the problem from 1 microcoulomb. How much distance? Na? Here shall I write? This is the first charge and this is the second charge. So F1 is here nullified by F2 only, na? Yes or no? So what I can write? F1 equal to how much? F2. What is the force between the first charge and this 1 coulomb? Respond. A into 1 microcoulomb into 1 coulomb whole divided by x square. What is F2 meaning? Force between this second charge and the 1 coulomb charge.
Yes, sir.
How much? K into
Minus
2 into minus not equal magnitude. Taking magnitudes only. Did I tell F1 vector equal to F2 vector? Did I tell? If I tell F1 vector equal to F2 vector, it is incorrect statement.
Sir, x equals 2 by
F1 vector equal to minus F2 vector. But magnitudes are, I mean, numerical values are same. Tell me.
Sir, x equals 2 by root 2 minus 1.
2 by
Root 2 minus 1.
root 2 minus 1. Okay. And k into 2 into how much? Again 1. 10 power minus 6. 10 power minus 6 will be cancelled, my dear
Yes,
friends.
sir.
And into divide by how
D
much?
plus x plus x. D plus x.
2 plus x to the whole power 2. K cancels out. What do you get then?
2 plus x.
2 plus x by
X by
x
x.
whole power 2 equal to how much here? 2. Square I am sending this side. What will become? Root 2. What I can write here? 2 by x plus x by x equal to 1. equal to how much? Root 2 plus 1. If you bring this side, minus x I am sending here. This one I am sending this side. So what you will get? X equal to 2 by root 2 minus 1 is the correct answer for this. Srinidhi told perfect. Understood? Here is that partially went wrong. Partially wrong means fully wrong. You lose marks. Understood? Okay. Now, one more small practice problem I will give. You people have to answer it nicely. See here, this is one point charge. What is this? Some point charge of Q coulomb is the question of the day. This point charge Q exploded into two fragments. How many fragments? Two fragments. After explosion, two fragments will happen. No?
Yes, sir.
Let's say one fragment charge is small q, but another fragment charge capital Q minus small q. Let's say the separation equal to how much here? X meter. Now my question, for what value of charge? For what value of charge? For what value of charge? Force between them. Force between them is maximum. This is the question of the day. Hint also I will give. Why? Because everyone have to respond. Everyone have to send the reply. If y is a function of x, y depending on x, if y is maximum, if y is maximum, what is the condition? Y is maximum. Y value is on y axis, x value is on x
Derivative
axis.
dx must be equal to
Y value maximum means to draw in a tangential line, slope should be 0. What is slope of the y and x curve? dy by dx. What is the condition? dy by dx must and should be 0. It's a crucial thing. The JE question only.
Here, where is y?
Where is F? Y is similar to force between the two charges. X is the small q.
capital Q.
Small q. Capital Q is always constant, na? Only small q alone changes. Okay. So try seriously and think in all directions. Okay. If you fail also no problem.
That means you have to
If
find
you
out-
send 2-3 answers also no problem, but compulsory you have to do.
Sir, you have
Understand?
to find out small Q or capital.
You have to find small q.
Oh,
For what value of small q? Sorry, my mistake only. Small q you have to find. Capital Q is fixed only.
yes, sir.
Small q only will change. Okay. Try everyone and find a second question maximum force also. The first question, you have to find small q value, and what is second question?
Find the maximum.
Find the maximum value of the force also. Okay. It is a past year question only. Year and all these things I did not remember, but everyone try seriously. So I will be waiting for your response. Okay, now take 5 minutes break. Okay, bye. Thank you. Now you take